Okay, guys, we are going to start this review. Um, if you guys have any questions about this after watching, don't hesitate to send me a message, text, email, whatever. I'll try and get back to you as soon as possible. All right, so this first question says that the seat on the carnival ride is fixed on the end of an 8-meter long beam, pivoted at the other end. If the beam sweeps through an angle of 120 degrees, what's the distance through which the rider moves? So what is it wanting us to find? It's wanting us to find distance. When it says specifically distance, then it's wanting us to find x, like linear distance. And it actually gave us circular or rotational distance when it gave us the degree. So theta is 120 degrees. And it also gave us this 8-meter long beam. So think about it. If there's a beam and you're on a carnival ride that's fixed at the end of it and it's making a circular path, then the length of that beam right there is the radius. Okay, so just wanting to point that out. So we have a radius of 8 meters. And so if you go through your equations, you should have one that looks like this. So if you go through, and now, as far as this is concerned, what have I been telling you guys that the unit needs to be? Is it supposed to be in degrees? No, it's supposed to be in radians. Hopefully you guys are saying that, even though I can't hear you. So you've got to convert that over. So 360 degrees is the same thing as 2 pi radians. And you multiply that by 8 meters. You should get, with significant figures involved, you should get 17 meters. Okay, so if it asks you to find distance, then you have to go through and figure out, like a linear distance. Okay. All right, going on to the next one. An elevator cable winds on a drum of a radius of 90 centimeters that's connected to a motor. If the elevator moves down at 0.5 meters per second, what's the angular speed? So angular speed, that's W. Okay, so go through your equations. What do you have? Well, you have one that looks like this, right? Or WR, however you want to say it. And if you rearrange that to solve for angular speed, then you end up with this equation. So, do we have all of that? Yes, we do. And then our radius is 90 centimeters. So see how this top one is in 0.5 meters per second? We got to get that 90 centimeters in meters. So 0.9. If you do 0.5 divided by 0.9 on your calculator, you should get 0.56. Your meters cancel, so you're left with radians per second. Okay. The next question is asking us to find if the elevator moves down 6 meters, how many revolutions has the drum made? So this is wanting us to find revolutions. Okay, so it's giving us 6 meters. 6 meters is a linear distance, right? So do we have an equation that can get us from linear to circular? It's this exact same equation as number 1. So if you rearrange this equation to solve for theta, okay, so just put in 6 meters divided by your 0.9 meter radius again. So if you take 6 divided by 0.9, you should get 6.67-ish radians. And it doesn't want us to find radians, it wants us to find revolutions. So you have to convert that over. So 2 pi radians is 1 revolution. So multiply by 1, divide by 2 pi, you should get 1.1 revolutions. All right, and then part C, it says, what is the drum's frequency of rotation? So go through your equations again. I gave you a paper that has those. You should have one on there that looks like this. Angular frequency is equal to 2 pi frequency, or angular velocity, either way. So frequency, if I'm solving for it, now, do I have the angular speed? I do, which is this 0.56 radians per second. If I wouldn't have had angular speed, say I would have had linear velocity, like up here, you could have taken this equation right here and plugged in for that. So sometimes there's, situations where you'll have to use multiple equations, unfortunately. Probably won't be like 15 minutes like that one, though. Although, I don't care what you guys say, that was an excellent question. It was stuff from every single chapter we've done so far this year. So, when I did that, I did not get 0.088. I got 0.88. So let me change that really quick. Sorry about that. Make sure really quick. Nope, it is 0.088. Gosh darn it. I'm not re-recording this though. I've already gone too far at this point. So that is a parentheses thing. What I did on my calculator is I did 0.56 divided by 2 pi without parentheses, and that's why it gave me 0.88. So there you go. Be careful of doing that. It could happen to you too. All right, so we are on number 3. Number 3 says that an apparatus is designed to study insects at an acceleration of magnitude 980 meters per second squared. The apparatus consists of 2-meter rod with insect containers at either end. The rod rotates about an axis perpendicular to the rod at its center. So if you think about it, you've got this, 2-meter rod, and it's saying that the insect container are at either end. So here is our radius then. So with that, instead of this being 2 meters as the radius, we need to remember that the radius is going to be half of that. Okay, so just keep that in mind. Sometimes, it's worded one way or the other, and you have to kind of figure out if it's the radius that it's giving you or if it's giving you the diameter. So it also gave us the acceleration here of 980 meters per second squared. So this wants to know how fast. So it's wanting us to find v. Do we have an equation that has acceleration and velocity in it and radius that we've been using? It is one that you should have used on your simulation last week. We've been using it multiple times on the PowerPoint, so hopefully this looks familiar. If you rearrange it to solve for just velocity, you should have the square root of acceleration times radius. So we've got 980 meters per second squared times the radius, which is that 1 meter, not 2, and that should give you around 31 meters per second. So then it wants you to find what is the angular speed of this. So just to kind of go through the other equation that involves radial acceleration, we'll do that. You could use this as well, but I want to use this one since we haven't yet. So we've got 980 meters per second squared. If you divide that by the radius, so this 1 meters, and do the square root of that, I just rearranged this equation and solved for W, then you end up with 31 radians per second. Okay. Doesn't always happen like that, obviously, but we were dealing with one, so. Okay. And probably can do one more on this video. So this one, a curve in a stretch of highway has radius 512 meters. The road is unbanked. The coefficient of static friction between the tires and the road is 0.7. What is the maximum speed that a car can travel around the curve without skidding? All right, so let's write some stuff down first. We've got a radius of 512 meters. We've got a static coefficient of 0.7. So if we go through and we do our Newton's second law here, so we've got normal minus mass times gravity is equal to 0 because the car isn't going up and down. It's going on a road in a circle, so it's still like in the X. And then, so for our radial force in the X direction, our only force is really the static friction, and we can set that equal to mass times acceleration, which the acceleration is radial. It's going in a circle. So if we remember our equation from up here, we can plug that into our radial acceleration right there. So we have mass times velocity squared over r. Okay. Now, you've got to remember too that static friction is equal to the coefficient times normal, or normal is mass times gravity. So if you set that equal, when I say if you set that equal, I mean if you put that in for that right there. So I have this is equal to this, because remember this part of the equation I changed to that. Okay, so it was static friction is equal to this, and I just covered up the r, but hopefully you guys are staying with me at this point. Now, if you rearrange and solve for the v on that, you end up with the square root of r times static friction times gravity. Your masses end up canceling when you move them over like this. You multiply both sides by r, you end up canceling those masses right there. And then since that is squared, you have to do the square root. So if you plug in the 512 and 0.7 and 9.8, and you do the square root of that, you should get 59 meters per second. Okay, and then it just wants to know what happens when a car enters the curve at a greater speed than that. Well, then it skids, obviously. It's going to skid towards the outside. Once a free body diagram, you know, we got our normal, you've got your weight, and you've got, that was terrible, you've got your friction. Okay, so I'm going to go ahead and stop the video. My pencil's battery's getting low anyway, and then I'll make another video.